But yeah, thanks for now. And now the next presentation of this session, it's on airborne wind technology. And we'll have Tobias Broening, that he has quite a big background in working with energy giant FMC. But since 2020, he works in SkySails Power, where exactly they develop airborne technology. So now he will tell us a little bit more about this. And of course, this some of you can say this is not really small wind, but in our eyes, this is something that can be both a competitor and at the same time a potential helper of small wind, that it can reach sectors that small wind itself cannot reach. So that's why we decided to invite also these players on board. Tobias, here I can see the presentation, so the floor is yours.
Thank you very much, and thank you very much for the introduction, and thank you very much for having me. I believe my camera is on and I'm sharing the screen, right?
Yes.
Okay, fantastic. I believe what I would like to show you today is something that you are not necessarily familiar with, which is why I have included a small video in the beginning. It's only 90 seconds, but the idea is that we all get onto the same page what on earth I will be talking about. Maybe
sorry to interrupt you. When you share the screen, you should have view options on top, and then you can optimize for video playing and audio. So you have the option to do that. Otherwise, you can exit from the share screen and share again, and then you have the options just there.
Here, the video clip optimize. Okay, let's see. If it doesn't work, please let me know. Maybe to start with, as a quick introduction, we at SkySails believe that the time to introduce a radically new technology has never been better than it is today, because the pressure on each country and on all individuals has never been bigger to come up with something that helps us to avoid emissions wherever we can. Solar clearly is a well-established technology, as are wind turbines, but we believe if we as mankind are serious about the energy transition, we need to tap into additional energy sources that we are not currently using. And we consider our technology not in competition with turbines or in competition with PV, but as an additional technology that will help us to close the gap between our energy demand, our energy need, and what we are able of producing today. Here comes the small video, and I hope you can see it. I hope you were able to see the video.
Yes.
Okay, fantastic. So as you can tell from this very short introduction, our technology is radically different from everything we have seen before. And there is a particular reason why we have developed this. As you all know, it is important to harvest energy from wind as high as possible, because the friction on the surface is slowing down the wind. And the higher we go, the more continuous and the stronger the wind becomes. The energy density of the wind is increases exponentially with the wind speed. And if we want to generate a substantial amount of electricity, it is very helpful to go as high as possible. Now, there obviously is a physical limit on how you can build a wind turbine because of the complexity and the weight of the structure. What we are doing is we detach the energy production system from the mechanical components. What we have is a ground station that is nicely sitting on the ground, and we fly a kite several hundred meters high where the energy is available. And by doing so, we avoid the need for a structure to put the generator, the turbine, etc. onto a monopile. If we go to greater heights, we very easily see that most of the world's surface has sufficient wind to profitably run wind energy production systems such as ours. And this is only a very small comparison. If we look at the wind speed at 10 meters altitude, we find that good wind conditions are usually offshore or somewhere on the coast, while if we look at wind speeds at 200 meters altitude, we find that most developed countries and most of Europe have very good wind conditions. The way our system works is that we launch the kite, which is what we have seen in the video. And for the kite surface of view, we maneuver the kite into what's called the power zone. This is where a kite produces the maximum pulling force on its tether, which is this rope here. The whole system is autopilot controlled, and we keep maneuvering the kite in this H-shaped figure exactly in the power zone where the energy yield is the biggest. And while we do so, the kite pulls the tether, a very long rope, from a winch, which is connected with a generator and produces electricity. The tether has a length of 800 meters, and when it is fully used, we fly the kite into a neutral position where it creates very low pulling force, and then we rewind the kite and pull it back down to a lower level, and then the whole cycle starts again. The press very often refers to our system as a yo-yo, because the kite keeps going up and down, up and down, up and down, pulling the tether from the winch and then being rewound. So this is a continuous process with a power generation phase when we have the kite in the power zone, and a rewind phase where we take the kite back down. The system consists of a number of components, of which I would only like to mention a few. The ground station is where all the technology sits. This is where we have the large winch, where we have the generator, all the control units, all the electrical components, etc., which, as I said, is sitting on the ground, easily accessible for all sorts of maintenance. Then we have the flying system, which consists of the kite itself and a control pod, which we also call the autopilot. At every point in time, the kite is fully controlled. At every point in time, we know exactly where it is, what it does, how fast it is going, what the local wind condition is in a given height, and we can maneuver it left and right and up and down as we wish to optimize the energy yield. When we look at the LCOE of such a system, we find that right now we are, depending on the site, of course, looking at cost of electricity of something like 20 euro cents per kilowatt hour. Because as a young company, we are currently in a pre-series phase. We have sold some 10 units, but we are not yet at serial production. So right now the cost per system is rather high, and as a consequence, so is the LCOE. The markets we are currently targeting, therefore, are usually off-grid installations where the current source of electricity is a diesel generator or something that has an equally high LCOE. Moving forward, we are expecting to take the LCOE down to more competitive levels over the next few years, and eventually we will reach an area where we can compete with classical large-scale wind turbines. But that's more looking forward. That's not where we are right now. One important point here is that, and that might be a differentiator from other technologies, the most important driver of LCOE and energy yield is the flying system. It is the kite. And the kite can very easily be changed to either adjust for changing weather conditions or to implement technology improvements. Changing the kite takes like an hour, and we have obviously different sizes and different shapes to account for different wind situations. So the system can quite easily and continuously be improved as our technology develops. It does, however, require a substantial amount of space. I briefly mentioned that the length of the tether is 800 meters, which means that potentially the kite can cover a circular area with a diameter of almost 2 kilometers. And this makes the system usable in only lightly inhabited areas, because we would like to avoid flying over structures, over people, over buildings, over streets. So the whole system is designed for off-grid installations where there is sufficient space available. However, this is a safety measure. The flying altitude of the kite is between 200 and 400 meters. So we are much, much higher than anything that people would build. And we are far away from everything, far away and far above people's heads. We can use the system as a single installation, but we can also combine several units into a small wind farm, depending on how much electricity is needed. To give you a rough estimation, the system that we are currently shipping has an annual energy yield between 600 and 800 megawatt hours. And these are figures from our installation that we've seen in the video. This is in northern Germany. It is an installation that is fully integrated into the German electricity grid. It is on grid. It is all the approvals and certifications to feed electricity into the national grid. It is an R&D site where we're still working on improving our product there, but it is a technology that is ready to be deployed. What's the benefit? Very briefly, if we harvest energy at heights between 200 and 400 meters, we find very, very constant wind conditions, which means that our technology is capable of producing electricity up to 90% of the time, which is an equivalent of some 6,000 full load hours a year. This puts us into the range of base load capability. So our system is designed to supply villages, industrial installations with more or less continuous electricity. In terms of LCOE, we have seen that over the last 2 years, we managed to cut our local LCOE into half, and we expect this development to continue. Right now in northern Germany, we would probably be looking at something like 15 cents per kilowatt hour with a calculated lifetime of 20 years. And we expect to reach the 10 cents per kilowatt hour range in 2023. We already had a very brief discussion on not in my backyard or please in my front yard. This system is almost invisible for people living around it, because the ground station is containerized and is very small, is sitting on the ground. The kite itself is flying in substantial altitudes, and it is usually out of people's sight. I'm not sure what the English term is. In Germany, the system has been certified as not raumbedeutsam, which means that it has no measurable impact on the environment, and that's important for Germany to know. Legally, no one can complain that it is ugly or disturbing, and that's a differentiator from classical wind turbines, because as you all know, there is significant pushback from people sometimes. So it is minimally invasive. It is quite silent. It has no visual impact. The land use is minimal because it only has the small container, and it is mobile. When we think of how difficult it is to install, any place that is accessible by car is accessible and usable for our system, because we need no big crane, we need no heavy concrete structure to support the system. It can basically be put anywhere where there is sufficient solid ground. Yeah, that's supposed to be my contribution to today's discussion. It might be a little far stretch because it is so radically new and different, but we are deploying the system worldwide. We're targeting developing countries as the entry market, but we see a clear development also in Central Europe to create electricity more decentrally and in locations that are not usable for classical wind turbines, for instance. And that's coming back to my initial statement. We believe that for the energy transition, a multitude of different technologies will be needed, and our airborne wind system, harvesting electricity from very high altitudes, should be one of those solutions. Yeah, thank you very much for your attention. I'm more than happy to explain more or to answer potential questions anytime.
Thanks a lot. It was a really interesting concept. And yeah, I can see there is already a question from Marcus. You're welcome to unmute yourself.
Thank you. Coming from a safety security background, I have to ask, what happens if you, for some reason, lose control of the kite, or even have the rope breaking or something like that?
Yeah, there are a multitude of safety measures put into place, obviously. First of all, the system has an emergency landing capability. So if anything happens to the grid or to the electricity supply, the system will automatically land. That's the first. A defective tether or a kite out of control potentially is the biggest risk. If the tether breaks, the kite will sink down like a parachute. The weight of the kite is below 50 kilos, including the autopilot. The size of the kite is something like 100 square meters. So it will just very gently land somewhere. We will certainly try to avoid that, but the impact is minimal. In fact, there is a safety device. If anything goes seriously wrong with the system, we will automatically detach the kite from the tether, because having it go down like a parachute is the safest emergency way out.
Okay, thank you.
Thank you. Any more questions? If not, I have one actually. We have talked about acceptance, and one of the issues that we see normally with larger wind turbines, it's the problem of birds. And we know there has been studies done on that and so, but the perception of people is still saying wind turbines kill birds. Yeah. What about this? Because you will still have some kind of cable connecting to the generator on ground, and that might be a challenge for birds because it's harder to see. Have you considered this this option?
Yes, we have done a number of studies with birds, and that probably, you're right, is one of the biggest concerns that people have. What's the impact on the avifauna? How do birds react? And honestly speaking, we found that birds don't care about our system. They usually do not fly as high as the kite. So where birds live is far lower than the average flight altitude of the kite. So the real obstacle and risk for birds is the tether, is the rope. At high altitudes, the tether is moving substantially. Something like 15 meters per second is the speed of the kite. But physically, if you look at, here's the camera, if you look at the length of the tether, if it moves very fast up here, the movement at the bottom is minimal. So at the altitude that we usually find birds, the tether, the rope, is moving quite slowly. And since the diameter of the rope is 14 millimeters, so statistically, it is very unlikely that you hit a bird with something that is so small and moving so slowly. It's not impossible, but all our studies have shown that there is very, very low risk for birds. The other effect is that you have this vacuum effect behind the blades of large turbines, and this simply doesn't exist in our technology. So there is no vacuum behind the kite or anything.
It's good that you consider also these aspects while designing, because they can really be a problem afterwards for acceptance. So it's
it does. Also, the system that we've shown on the video has been in operation for 2 years, and 4 weeks ago we had a big conference with all the people living around the system who are watching the system fly every day. And their feedback was extremely positive. You might have seen on the video that there are a number of wind turbines around, and they confirmed that the impact that our system is creating does in no way compare to what a wind turbine does, because it's not static. It has no continuous patterns. You don't have shadow flickering effects or anything. It is strange because we're not familiar with it, and it's, you know, it's kind of nice and strange and unusual, but the feedback was extremely positive. And it has to be if we want to introduce a radically new technology. If there's pushback now, we can expect pushback all the way, and that's not what we hear.
No, that's true. But yeah, I can see time it's up again. If there are some more questions, you can either put them on the chat or ask them later in the networking moments. Now I would like to thank you for this, of course, and we will close the session of innovation, and we will pass to the session number 2.